All right, class. Today we're working on Unit 2, Lesson 2, Properties of Exponents. Problem number 1, we have 7 squared times 7 to the third power. So the first thing we're asked to do is to write it in exponential form, and then after that, write it in standard form. So often I'm going to be referring to, we call this format A and format B, or scenario A, scenario B. This first one, we have 7 squared times 7 to the third power. So I'm going to look at this and see which one of these it most resembles. And I see that it looks just like method B. Base raised to an exponent times another base raised to an exponent. In this case, we keep the same base and we add the exponents. So I'm going to write this as 7 to the 2 plus 3 power, and then solve that as 7 to the 5th power. And now in today's, they want us to do standard form. So anytime you have a number, an actual digit raised to an exponent, we're going to work it out and get an actual number that's not raised to any specific exponent other than 1. So 7 to the 5th power equals 16,807. So that's a big number. I'm going to double check it. 7 times 7 times 7 times 7 times 7. Yep, that's a big number. Gets up there quick. Problem number 2. 3m in parentheses raised to the second power. Or you say 3m, the quantity of 3m, let me rephrase this. Quantity of 3m raised to the second power. That way you know that the 3 and the m together are being raised to the second power. And now if I was trying to compare this with method A or method B, I might be a little bit confused since I don't see any exponents going on the inside. So remember, anytime there's nothing written for an exponent, it means it's a 1. So we can go ahead and mark 1 and 1 in here. So now we can say, okay, we have a base raised to an exponent in parentheses with an exponent sitting outside. That looks like method A. In method A, we go ahead and look at the base, the exponent, and the exponent outside, keep the base, and multiply the exponents that are visible. So we have 2 times 1, so I'm going to rewrite this as 3 to the 1 times 2, and then I'm going to bring down the m, 1 times 2. And that simplifies to 3 squared m squared. And now to take it to the standard form, we take 3 and actually square it. Do the work. 3 times 3 is 9. And then the m squared tags along. Problem number 3. A little bit more squirrely looking. -2 raised to the third power times -2 raised to the third power. So these parentheses are important because they help keep that negative with the number. If we didn't have that negative with the number, you're going to get a wrong answer when you actually expand it out and find the standard form or the standard value. So these parentheses are very important. So now comparing it to A or B, I see base raised to an exponent times base raised to an exponent. Base raised to an exponent times base raised to an exponent. Remember, you can have something such as A in parentheses, get it for its little tail there, times A in parentheses to the m power. And that's basically what we have here. We just don't have a little dot written. That's fine. We can put a dot there. So now for exponential form, we're going to go ahead and add these. So I'm going to put -2 in parentheses and then 3 plus 3. So you see what's happening. Following the format B, and now that equals -2 raised to the 6th power. And for my last part here, we're going to be going -2 times -2 times -2, -2, -2, -2. So negative raised to an even power is going to give us a positive answer. So now I can just think of it as 2 raised to the 6th power, 2 exponent 6, and we get 64. positive 64. Problem number 4, x squared y raised to the second power. So now, trying to match this up with form A or format B, we have bases with exponents, even though there's nothing written here, that's a 1, raised to an exponent on the outside. So this is going to be another format A. So I'm going to write this out as x to the second power times the outside exponent, which is 2, and then carry on my y. Its exponent's a 1 times the outside exponent, which is a 2. And now to simplify that, we're going to have x to the fourth power, y to the second power. And now, since there's no values such as 3 squared or 7 to the fifth or negative 2 to the sixth power, I'm not going to have a nice number to work out over here. So when I see an exponential form, it's going to carry straight on over to standard form. There's nothing else to do. So my answer here is still my answer over in standard form. Number 5, x to the third raised to the seventh power. Classic example of this. X to the third raised to the seventh power. So we're going to take x to the 3 times 7. Write that out. X to the 3 times 7. And that works out to be x to the 21st power. And same thing as with number 4. There's no numbers out front. Like there's no 3 squared, there's no 5 squareds. So what we have in exponential form is going to carry over into standard form. Same answer, both spots. Last one, we have 5 in parentheses squared, and that to the third power. So now there's a whole lot of parentheses going on, but are they necessary? Inside here, it's a positive 5. We don't necessarily need to put parentheses around it, but we'll let it be, just because I think they're trying to razzle and dazzle you with all these parentheses and see what effect they have. So this 5 inside here is still raised to the first power. So this is just a glorified version of method A. Inside exponent multiplies with outside exponent. So we're going to take 5 to the first power times it by the outside exponent, which is 2. And then we're going to multiply that times the outside exponent of that set of parentheses, which is 3. So we're going to have 1 times 2 times 3. 1 times 2 is 2. 2 times 3 is 6. 5 to the 6th power. And so now we have a number raised to an exponent. So I have something to work out and write in my standard form. So 5 to the 6th power gives me 15,625. So that is your Unit 2, Lesson 2, work with exponents and their properties. Thank you.